All right. So, anybody auditing the class or not registered? Okay. You are. All right. I guess there's plenty of seats for everybody, so there shouldn't be an issue. And also, all the material will also be available on Piazza. So if you can't get a hold of the material on Blackboard, you'll also be able to see it on Piazza. Right? So this is the syllabus. We'll be meeting here on Wednesdays from 6 to 9 for all summer long, except maybe 4th of July. Is that Wednesday? Is that a Wednesday? I know there's somewhere in there. And it falls exactly the same, we're about the same week where spring break met in the spring. So that was interesting. We'll meet here Wednesday from 6 to 9. I don't have the entire teaching assistant. I'm still looking for a couple more teaching assistants. If you know anyone, let me know. So we're here to talk about databases and data management in general. SQL has been king in data access for quite a few decades. We see that there are many other alternative ways of storing data, retrieving data, especially since now we have big data. We're generating more data than we can ever consume, that we can ever process. So there's a whole different types of issues on how to handle that much data, right? So a lot of data mining, a lot of big data issues. So every time we wave our phones, we generate a stream of data that somebody else is relating with something else, trying to identify things about us. So the first couple of weeks are going to be a lot of relational databases, SQL, inserts, updates, deletes, selects, creating data models. Then halfway through, we'll change a little bit, and we're going to look at other alternative ways of storing data, such as XML, JSON, NoSQL, and then how to integrate that data and share amongst other disparate applications that might want to use the same data. How do you integrate folks that are storing it using a relational database with folks that are storing in XML, with folks that are storing it in non-SQL? How do you integrate all those things? So we'll talk about exposing things using web services and different ways that we can map that. There'll be about six assignments, about one every other week. But then the week that you won't have an assignment, you'll have a project-related assignment. So those will be the course is heavily based on you working on a project that you can create groups of between 2 and 4 students per group, and you're meant to work together. So the assignments are for you to work on individually, and typically we'll work things together here in class. Then you'll complete assignments, and then whatever you learn on that assignment, perhaps you get to use that on your project. So 1 week will be assignments, some coding assignments, and the other week will be a milestone, a project milestone. The first one will be to just research on what it is that you want to work on for the rest of the semester. If you're taking web dev with me and databases with me, it doesn't count. You can't have the same project for both. They have to be completely different projects. Especially also because you'll probably have completely different team members, or maybe not. I recognize a lot of the same folks from web dev this afternoon. The project is worth 40%. Quizzes. There'll also be quizzes. Again, every other week. Although I might bump that up. It encourages you to come to class, especially the nice summer days. It's hard to have you here. The final grades pretty much following the standard. Generally there is no makeup policy. If you miss something, you missed it. But the assignments will have bonuses that if you miss something, you need some extra credit, some more. You can work on those bonuses towards anything that you might have missed. Also, the late policy is that you lose one point for every hour that you're late. So there's no need for you to ask for an extra time, right? It'll cost you how many hours you want. If you need some 3, 4, 5 hours more, it'll cost you 3, 4, 5 points of the grade. So that keeps it simple, minimizes any administration costs to the TAs and myself. Assignments will typically be through Blackboard. Many of the assignments will consist of you submitting some GitHub repository, some commit URL that you push onto GitHub, and then you would copy and paste that URL and submit that as your assignment. Some of the programming assignments you'll need several libraries to get them going. For instance, JDBC or JPA or any jar files. Typically, we're going to be using Maven to be able to declare any dependencies of your project with other libraries. So it has to be compilable in our machine. So the TAs are going to clone down your project. They're going to do a Maven clean install. It'll build, and they should be able to just run it from the command line. Typically, it'll be it'll have to print out some expected output. Do several inserts, do several queries, several updates, and then print out some particular result. For the so the assignments are meant to be worked on individually. The projects certainly you're meant to work together. You can discuss the assignments amongst yourself, but don't look at anybody's shoulder or share any code. The project again, that's in team, so you'll be submitting one single project. If you find that your teammates are not participating or collaborating as much as you would like, you need to bring that to our attention early, really early in the semester. If you bring it towards the end, there's be very little that we can do for you. The grade for the project is shared amongst all of you, and if you think you're gonna your grade will suffer because someone else is slacking, whatnot, you need to tell us early, right? We don't want it towards the end of the semester saying, oh, but I did all the work, and so didn't contribute as much. If it's so late in the semester, there's very little we can do. Perhaps we can split you off, or we can rearrange you and you work on something separately. The project will be the same requirements for everybody. So most of you will fall within those requirements. You're free to choose whatever topic you want to work on, and as long as you're within those requirements, you're free to do whatever you want. Most of you will fall within those boundaries, but if you feel that you want to step outside and explore other things, certainly we can negotiate. One feature for another feature, right? So it says, I don't really want to do this particular requirement that you have. Could I instead do this? Okay. So please come to me if you have any questions. But if your project falls within the requirements, you don't have to ask. All right? You don't have to get approval from myself or the other TAs. Okay. And they're very general requirements, right? We'll ask you that there has to be some one-to-many relationship. There has to be some many-to-many relationship. Okay, there has to be a one-to-many relationship between one user and another user. Whatever that relationship is, you can choose whatever that is. Somebody follows somebody else. That's a one-to-many. Well, actually, that's a many-to-many, right? There has to be a one-to-many relationship between a user and some domain object. Whatever that domain object, it depends what domain you choose. That could be a playlist, it could be a movie review, it could be whatever you choose. Okay. So the requirements will be very generic, and at the end of the semester, we'll ask you to submit a repository where the project is the source code of the project will be available, and part of the milestones in your project will be to add multiple wiki pages where you will provide your progress of your project. For instance, one of the milestones is that you need to create some proof of concept, right? Where you might have lots of little experiments that you're testing that what you're building is feasible, right? And you might find that once you do the proof of concept that maybe you need to go back and rethink your requirements. Okay, and that's okay. You do some proposal at the beginning. You start your design, but maybe halfway when you do the proof of concept, you realize that it's not maybe it's too hard or maybe it's too easy, and then you need to rethink your requirements. Okay. But at the end of the semester, one of those wiki pages will be for you to provide to us step-by-step, very detailed step-by-step tests for us to validate that indeed you hit all those requirements. Right, so show me steps where I can validate that there is a one-to-many relationship between a user and another user. Right, so maybe it's a manager that manages multiple employees. Right, then you will show me what steps do I follow to verify that indeed some manager is managing multiple employees. The TAs will follow your instructions verbatim. So hopefully you have tested yourself these steps before submitting these. And they won't deliberately try to break your application. They will follow your steps verbatim. But you have to provide the steps for every single requirement that will be there. The TAs will typically will then randomly do some smoke testing here and there. Also, they will also look at the source code and verify that you've followed a good practice. Here we'll talk about lots of design patterns and best practices, and we'll verify that you have followed these design patterns in your source code. Okay. All right. So this is the schedule. No, that's not the schedule. It's not the schedule. Why is this pointing there? Yeah, you'll get a Piazza. You'll get a Piazza invite. There it is. All right, so this is the agenda. So yeah, today will be mostly introduction to the course, some very basic concepts in databases and data modeling. We'll talk about the first assignment. Next week we'll talk about more data modeling using UML for creating class diagrams, sequence diagrams, state diagrams. How to normalize normalization, first normal form, second and third, functional dependencies. All throughout the semester, you'll find me repeating over and over that what we try to do is remove any redundancy from our data. That the redundancy breeds inconsistency. One of the simplest examples is that imagine you had two watches, I guess analog watches. And that they're meant to tell you the same exact time, right? That's the concept. That's the idea. But over time, they are not synchronized, right? But for most of the time, they are. right? And for most of the time, you can look at either one, right? And it doesn't really matter which one you look at. They both give you the same piece of information, yes? But over time, for any reason, they might become not synchronized, right? And when you look at one and you look at the other, they're not the same, right? And then you kind of start kind of not trusting one or the other, right? And this is what we want to avoid: the trust, the lack of trust in the data, right? That folks are using enterprise databases to be able to query them, right? And get some information so that they can make some business decision, right? And they need to be able to trust the data, right? That if you query it, it's always going to give you something that represents reality, okay? And so we want to avoid any chance that that data is compromised in such a way that we cannot trust it, right? And one of the reasons why we might one of the things that we can avoid is inconsistencies, right? That we do some queries that should give you the same response, the same data, but it doesn't for some reason. And so you start thinking, what is it? We must have done something, right? Imagine you're capturing addresses for a family that's supposed to all live in the same house. And most of the time you query it, and yes, no matter who you query, it gets you to the same address. But perhaps people move, things happen, and now the addresses are kind of they don't represent reality. Folks no longer live in that address, right? And it might be because you captured multiple times, and it didn't matter who you queried, you always got the same address. But as people move, you didn't perhaps update the address that had been captured multiple times in the multiple records. So typically we avoid that by by removing any redundancy, by capturing any piece of information only once, right? And perhaps referencing. Everybody references the same piece of information, so as opposed to copying it in multiple places. So you're going to be that over and over about avoiding redundancy to avoid the risk of inconsistency. And how do I deal with that with identifying functional dependencies and normalize. Typically, we avoid that by normalizing the data, right? Breaking it up into the smallest constituents. We'll talk about modeling using UML, which is a conceptual way of modeling, right? It's just graphical. It's a universal modeling language. And then we'll look at concrete ways that you model those things, right? You can take the same UML diagram, class diagram, and then represent it either as a relational database schema, right? Using tables and records and whatnot. But then you can also represent it as a Java class, or as a JSON object, or as an XML schema. So the same conceptual data representation, data model can be instantiated in any number of ways, right? Depending on what you are trying to do with that data, even though it's the same data model, right? But all these concrete ways of modeling or instantiating that data model might be inconsistent amongst themselves, right? Where a relational database is fairly flat, a object-oriented Java is very hierarchical, right? So a lot of the things that you can do in object orientation, you can't do in relational databases, right? A lot of things that you can do in object orientation, you can't do in XML, right? Or things that you can do in XML, you can't do in Java, right? So even though they all can try and represent the same data model, there are limitations on what actually instantiation of that data model you choose. So we'll talk about it at a very theoretical way of representing data models, and then we'll start looking at one of the main ways that we create data models is relational schemas. Okay, but we'll talk about some of the limitations, certain things that you can represent in the conceptual model, but you cannot represent it in relational schemas. Right? For instance, inheritance. Right? You can certainly capture in a data model. We can't capture it in a relational database. Right? There are different ways that you can hack inheritance into a relational database. We'll talk about different ways that we can capture certain relationships, and pros and cons. Some of them are very space intensive. Some of them are time intensive, and we'll talk about that. We'll talk about queries. We'll talk about the fact that we've in our quest to avoid redundancy, we have normalized the data into multiple tables, into multiple silos that at some point they need to be reconstructed. Right? You might have user information in one table, addresses in another table, course information in one place, and if you want to query who's enrolled in what course, you need to kind of like get records from different places and kind of join them back together to be able to answer a question. And that's time consuming because the data has been spread across multiple collections. So we'll talk about what are the time constraints and processing that we need, and some of the optimizations that we could do to be able to improve some of that performance. We'll talk about SQL, all sorts of ways to interact, of creating data, updating data, inserting, and also be able to group data, having and whatnot. All the good stuff in SQL. So that fourth week will end our coverage of relational databases in general. We'll keep using it throughout the semester, but the first couple of assignments are dealing with a database at its lowest level of abstraction. Even though databases themselves are very high level of abstraction, right? There are no real tables, right? There are no real records, right? At the bottom is just a file with zeros and ones, right? We've created this abstraction of thinking about data in terms of tables and records. Okay, it's just a convenient way for us to think about how data is structured, right? But again, it's just one level of abstraction. So we'll start adding more levels of abstraction, right? So that we can add, communicate and interact with databases, not manually, but with some different APIs programmatically from Java, from JavaScript, from Node.js, different ways that we can interact with data programmatically. We'll talk about JDBC, which is the lowest level of abstraction from object-oriented programming. We'll talk about several design patterns on how to structure and organize data access from a program, and we'll talk about how to deal with SQL injection. Now that we're dealing with programmatic interaction with the database, we have to consider that there's some human being who's providing us data, right? Some raw data, and that raw data needs to be cleaned up and make sure that they're not maliciously or unintentionally or intentionally feeding us data that is malevolent and might hurt our database. So we'll talk about how to deal with SQL injection and prepared statements. Then we'll do some web database programming on how to integrate this data from using various web technologies. Very, very simple web technologies. This is not a web course. Even though most of you will end up doing a web course, it is not required that you do a web application. Usually I get one or two folks that do a mobile application. That'd be great if you want to try that. But if you're familiar with other user interfaces, that's fine. You could use other user interfaces. Some folks last semester somebody did a command line application, so it was all an actual command line, and that was valid. That was okay. So somewhere halfway through the semester there'll be a midterm. I'm thinking that perhaps it could be right before the 4th of July break. So probably what I'll do is I'll switch these 2 weeks and we'll do XML before we do the midterm, and then you'll have the 4th of July week. So yeah, so probably I'll switch these 2 weeks. Then we'll do some XML, which is yet another way of representing data. and you have the same issues that you have when you're data modeling for in UML, or you're data modeling to represent it as a schema in a database. The issues of redundancy, issues of referential integrity, same issues apply even in the XML. XML used to be, or still is, as a very popular way of formatting data and sharing data across disparate systems. So we'll spend some time on manipulating XML documents, generating, parsing, and mapping through multiple schemas. So for instance, it'd be nice to map an XML schema to a Java schema to a relational database schema, and see what are the challenges, right, of transforming data amongst all these different tiers, all these different that are supposed to be representing the same exact data. Okay, we'll talk about some of the challenges there. Then we'll do some NoSQL. In particular, we'll talk about use MongoDB as one of many kind of newer databases that have tackled the big data problem head on, right? That for storing data that is not necessarily has any particular schema, that can have a very fluid schema, right? That it's not necessarily structured, right? That you need to kind of find what the structure of the data is. You just need to just store raw data that you can then process and analyze. So we'll talk about NoSQL and how to interact with it using various libraries such as Mongoose is a very common library to talk to Mongo. Then we'll talk about how to expose this data so that if you have multiple systems that might want to share this data, you might have an enterprise database that needs to integrate with other businesses, right? Other partners, needs to integrate with a financial institution, with a governmental agency, with with their providers, with it needs to be able to share all this data to maintain its competitiveness, and it's very complex when you have these systems. Some of them are running .NET, some of them are running Java, some of them are running different infrastructures. How do you integrate all these systems? Very common technique was to wrap them in some web service endpoints, right, that allow you to expose the data and interact and integrate them. So we'll talk about that and RESTful web services. After having spent some time programmatically interacting with databases using low-level JDBC, we'll introduce a higher level of abstraction, such as which falls under the umbrella of ORMs, or Object Relational Mapping, that allows you to map a data model to another data model, right? And there are many libraries that allow you to do this. You just ask it, I just want to map this XML to that table over there, right? So whatever I do to this XML, this happens to my records in my database, right? Or Java classes and instances, and map them to some database and records in a relational database. So we'll talk about ORMs in general, but in particular, we'll spend some time talking about JPA. Finally, we'll talk about transactions. Concurrency. These databases are meant to be used by hundreds, thousands, tens of thousands, millions of people using the same exact database. How do you handle the fact that multiple people are reading the data, multiple people are writing to the data, right? How do you make sure that we're not trampling on each other, right? That we're not stepping on each other's toes. So we'll talk about transactions and how to manage concurrency in databases. And finally, the last week we'll talk about how to optimize queries. One of the typical ways of doing it is to have databases index and create structures to facilitate the retrieval of data, right? To make it more optimal to find what it's storing there. And we'll see how indexing is not always the answer. Most of the times it is, but not necessarily. Oftentimes indexing can work against you, and it's actually faster to just do a full table scan than actually use the indices. So we'll talk about when it's good to index, when not to index, and other optimization strategies. So the last week that we meet is the final exam. Typically, it'll be that Wednesday, that last Wednesday that we meet, and then the project will be due that Sunday. Okay, and then the following week, Monday through the TAs and myself are going to be busy grading assignments. I'll probably be also looking at grading assignments for other courses. So I will be unavailable the week of the 16th week I will be unavailable. Right? And the grades are due August 29th. That's it.